In this episode of the podcast, I have an amazing guest who has come a long way from reporting unexploitable bugs to Google which were denied, through valid bugs and being on their Hall of Fame, up until working at Google and improving browser security mechanisms. The name of my guest is Michał Bentkowski. Enjoy! Hello Michał, thank you so much for joining me in today's podcast. To start off, can you tell me and our audience what is your background and how did you get to the point you are currently at? Start wherever you want to start.
Hey everyone, hey Greg. I started my career in cybersecurity around 10 years ago, and I was a pen tester for many years, and that was like my main job. I was always interested more in attacking than the prevention. In 2014, I think, or 13, I started Bug Bounty as a kind of a side job. I was hacking mainly Google programs like Google Web VRP and the Chromium, but I also reported like some bugs in some other bug bounty platforms. And after like many years working as an attacker, at some point I decided that instead of finding like an XSS number 100, maybe it will make more sense in trying to do some stuff that will prevent this XSS from happening in the future. Or maybe if we cannot prevent that, then maybe we can do something that will mitigate the side effects of this vulnerability. So in essence, I was on the offensive side, both in my daily job and in bug hunting, but like recently I started my shift from the offensive to the defense.
And where do you work now?
So now I work at Google. I joined Google at the beginning of this year. I am in the information security engineering team. We actually recently started a blog on bughunters.google.com, which is like the blog specifically of our team, which I think is pretty nice. And this team does many different things, but in essence, what I'm interested in is trying to prevent as many bug classes as possible. And the perfect way to prevent a bug class would be if that would be possible in the web platform. So like the developer of an application doesn't have to do anything, but we make some changes in the specifications or in the implementations of browsers. And thanks to that, like everybody is safer, basically.
Yeah, that's very annoying to us attackers when browsers make changes, because then it applies to pretty much every single application at once. Whereas when it's some changes in the server-side frameworks, like, I don't know, introducing prepared statements for SQL, it takes years, long years before everyone uses the new change. But in browsers, it's pretty much instantly after it gets to the stable branch of Chromium or whatever. It's just everywhere. So that's something I don't like.
Yeah, I think, from my perspective, that's pretty cool. Like, even if the application is not supported at all, but people update their browsers and the auto-updating mechanisms in browsers are pretty good, then they can still profit from the changes that we made. And yeah, in a nutshell, my job now is that the more I will annoy you, the better.
Yeah, unfortunately, that's true. What bug class are you working on at the moment?
I'm trying to prevent mutation XSS. That's okay. One of it. Basically, there is a change that I made in Chromium a few months ago to change how HTML is serialized, maybe how DOM tree is serialized to the HTML. Because the mutation XSS, like the root cause of mutation XSS, is that if you have a DOM tree and then you serialize it and then you parse it again, then you are not guaranteed that the first DOM tree will be equivalent to the second DOM tree. So I think, by the way, that it is a really bad feature of like HTML, because imagine that if you had a JSON, if you had an object and you would serialize an object to JSON, and then you deserialize this object, this JSON to an object, and you would get a completely different object, then you would say that it is pretty bad. But this is exactly what happened in the HTML, and it is actually by design. There is an actual warning in the HTML specification that when you do a run strip of HTML and the DOM tree, you are not guaranteed to get the same stuff that you get before. So there are basically two main surfaces on which we need to work with. And the first one is the serialization of attributes, because there was a decision made in the HTML working group, and that was like 10, 15 years ago, I think, that characters such as the less than character and the greater than character are not escaped in attributes. And this is actually bad because it might happen that something that was supposed to be an attribute will be mistreated as an opening tag. So it is actually a really slight change that I'm trying to make, is that when you serialize an attribute, then the less than character is serialized to, ampersand LT and the greater than to ampersand GT. But what's also like interesting and something that I need to work with right now is that we added a use counter to Chromium. So use counter is basically when we try to make a change that we believe can be backwards incompatible, then we are adding counters to Chromium, and we want to see how many people actually use a feature. So how likely it is to break the web.
Yeah.
And it turns out that, if I remember correctly, around 5% of page loads serialize attributes with less than or greater than characters in them, which is much greater than I had expected before. It doesn't mean that if we make the change, or like to, stable Chromium, the sites will break, but there is a potential that they might break. So we are doing some kind of analysis to see if this will really happen. And another problem besides attributes is that some tags, such as style, this is the most prominent example, when you serialize the style, then you don't do any escaping. So inside style, the less than character is just serialized as the less than character without the entity. And this also can be abused to mutation XSS. There is basically no way in the HTML spec to safely serialize a style tag, because if it contains the end tag if you use the DOM API and you set like style that text content is equal to end tag to style and then some stuff after that, then there is no way to serialize that safely. And I'm also trying to do something about that, but this is actually super, super tricky. And I am not even sure if that's possible at this moment.
Oh, yeah.
It is possible, but can we do that without breaking the web? That's the question. But when it comes to the attributes, it's also tricky because of the high percentage of usage. So we need to do some more analysis before we can say that it is safe to flip this flag in the stable Chromium. By the way, if you use the Chromium flag called enable experimental web platform features, then the serialization algorithm is changed to the attributes. So if you use that flag and if you see that anything breaks, please report a bug to Chromium or let me know, because I would be very interested in any use case that it actually breaks. I use that flag on daily basis for a few months now, and I don't think I saw anything breaking. But yeah, that's just like anecdotal, one person. That's not enough.
I think it can also, if I understand this correctly, it can also break some CSP bypasses where you could only inject an attribute and then you used, I think, Bootstrap with data HTML attribute and the value of the attribute became an actual HTML. So if I understand correctly, this will also break this CSP bypass.
I mean, if you use a DOM API like get attribute or like a data set and you get the value of an attribute, then it doesn't change. Like the parsing doesn't change, only the serialization. So I don't think that this bypasses will.
So serialization here means using what exactly?
That you have a DOM tree,
yeah,
and you create a textual output from the DOM tree. So you create an HTML text from the DOM tree. Because maybe let me explain why is this a problem, because I think I didn't explain that. The problem is like if you have HTML sanitizer, and well, HTML sanitizers usually work this way, that you have an input string that you consider able, and it outputs another string that is supposed to be safe. But what happens internally is that the HTML sanitizer parses the HTML, it traverses the DOM tree, and it removes everything that it considers bad. And then it needs to serialize to a textual output, to a string. But then when you do something like div.inner HTML is equal to like DOM purify sanitize something, then the HTML is parsed again, okay? Because the sanitizer serialized the DOM tree, but when you assign something to inner HTML, then it is parsed again. And that's the problem, because you might have a DOM tree that the sanitizer considers safe, but it is not safe after another reparsing. That's basically mutation XSS. So the problem is that, for instance, one example of a mutation XSS that actually happened in Google a few years ago, there's a video by Live Overflow about it. It was done by Masato Kinogawa. Basically, you have a no-script element in the HTML specification. And it is a very interesting element because it is parsed differently depending on whether you have scripting enabled or disabled. So if your scripting is enabled, then no-script is treated pretty much as style. I mean, it is parsed pretty much the same way. So everything inside is treated as text. But if you have scripting disabled, then it is parsed as div, basically. So two completely different parsing modes. And the problem is that if you use the browser-provided HTML parser, such as DOM parser, parse from string, then it parses the HTML as if the scripting was disabled. But if you assign
by default, is it disabled or enabled?
Disabled. You can change that. It is assumed that the scripting flag is disabled, and it's always parsed this way. There is like no way in the API to change that. But when you assign to inner HTML, then you obviously assign it to a document which has the scripting enabled. Yeah. So the problem is that the sanitizer parses the knob script kind of differently than how it will be parsed afterwards. So suddenly you might have a DOM tree that the sanitizer considers safe, and it like after that reparsing and the difference in script, it is no longer safe. There are other examples where after a few parsing trips you can have like different effects, but I think this is the easiest one to explain why this is a problem, why this might occur. And by the way, if you use a sanitizer that exposes like client-side sanitizer that exposes an API that it can return not a string but a DOM node, then use it, because then you don't have any problem with mutation XSS because the HTML is not reparsed.
Yeah. These things I got a little bit into, like knowing the more advanced or hidden, I don't know, you can say features of HTML, like namespaces and types of nodes and everything you say like here. So guys, if you if you are new to this, I recommend you blog posts by Michał. They are really good, and I'm not only saying this because you are my guest. I actually did mostly use your write-ups to learn about this stuff, which actually did lead to the to the XSS, let's say, in Golang's HTML library, which wasn't as advanced as those things, but I'm happy that I learned something. But I know that you didn't start your bug hunting career or your web security career by finding these, let's say, state-of-the-art XSSes. I think you started with the very simple ones. So can you tell me what was the first bug you ever reported?
I mean, when it comes to my bug hunting career, then the first bug I reported was an XSS in Google Blogger, and it was actually discarded. I mean, I didn't get a reward for that because the attack scenario was that I needed to send a zip file to the victim, and the victim needed to upload it themselves. So, yeah, I mean, I think I agree that, like, if I can make a victim do that, then I would just put something else in the zip file that would, you know, take over their computer. Yeah. Why bother with that XSS in that case? So that was the first bug I reported in Bug Bounty, but I think I reported some bugs before. Just like, you know, casually I found something in some library. I think like my first the first report that I did for some external software was to PHPMyAdmin. And I think that was in 2011, maybe, something like that. That was completely, inexploitable XSS. But there was a bug that I might, misremember the details, but it was something like that. That if you use like order by in your SQL query, then in the result, the PHPMyAdmin would say that these are results from to. And if you put an SQL comment in that, then it would just, reflect that SQL comment. So if you put like a snippet of HTML in that comment, then it would just, you had an XSS in that case. But it was inexploitable because that was basically, that was like a self-XSS pretty much. Because it has like cserv token and all stuff like that. But yeah, there was a bug that just didn't escape the data as they should, or maybe they should cast it to an integer. I think that's what they ended up doing. But I was thinking if I should report that or not because I knew it wasn't exploitable. But then I found it. Maybe they would say that, okay, it doesn't matter. I also didn't really brag about this report. I don't think I ever put that even on my Twitter or anything. Just there is a CVE for that, which I think is really funny. Because, but I think that like recently there's been a discussion about the usefulness of CVEs, and like somebody reported an SQL injection in the then vulnerable web application. So. Yeah, CVEs are pretty useless sometimes. But yeah, I got CVE from that, even though that wasn't. But I didn't brag about it because it wasn't anything special or anything exploitable.
Yeah, I think a lot of us just start with bugs that are not exploitable, and then as we go, we learn about the attack scenario and how important this is, that it's something practical. So can you tell me how did you then transition, let's say, from self-XSSes into ones that were rewarded?
Yeah, I think that my work as a pen tester was very so the work as a pen tester gave me really much here. Because I was talking to clients constantly, and oftentimes we had some discussions whether a bug is exploitable and whether we should consider this bug a security issue, or if it's like a high severity or medium severity or stuff like that. So like these discussions with customers made me, think more about the attack scenarios. And by the way, I actually am thinking about hosting a video on my YouTube channel about that, about the attack scenarios and when an attack makes sense, when it doesn't make sense. But I think, like during my pentesting career, like in security, I was a person who tended to lower the severity of bugs like the most of all people, because I remember, I think I won't share any specific details, but like some general idea. I remember that I was testing some application in like a pen test of an application, and I found a SQL injection. And at that point, in my head, SQL injection was pretty much an automatic, high severity or critical severity. But okay, I tried to exploit it further. And this was a SQL injection in an insurance application, and you could insure your car in that. So it turns out that the database contained only data about cars. So, models, manufacturers, types of engines and stuff like that. There was absolutely no data of users. And, when I reported the bug, and like automatically I gave it like high severity. But before sending this report, I just, stopped for a while and I was just thinking to myself, what if the customer comes back and asks me, why is this the high severity? And then I realized that I can't convince myself that this is high severity because I didn't, gather anything from that. Everything that was in the database was public data anyway. So I remember that was the first time that I lowered the severity of SQL injection. I don't remember to medium or to low. What was that? But it wasn't like high severity because it's just, I couldn't. How can I convince somebody else that it is high severity if I cannot convince myself? And I think that was a pretty important moment for me because it made me realize that you cannot just have an automatic assignment that this type of vulnerability is this type of severity. It's, all depends on many different factors, like what kind of data you can access, how likely the attack, like, I don't know, I guess that some people consider like stored XSS as more severe than reflected XSS. But it also doesn't have to be true in all cases. There might be cases where reflected XSS will actually be more likely to execute than stored XSS. Like if there is like a super common application like Google Docs, for instance, and if you have a reflected XSS in Google Docs, then, it's very, very easy to mount that attack. But if you have a stored XSS in a web interface of some network device that the admin visits once a year, then, this XSS might never actually get executed. So, I think that during my pentesting job, clients keep talking about that. The clients just like to not agree with the assignments of severity, and when it happens over and over again, then you start thinking about it more. You kind of like to prepare and to think about what they might say, what might be their arguments, what they might not like about this vulnerability, about this scenario. Oftentimes, it's difficult to, as a pen tester, you only see a fragment of the whole ecosystem. You might not understand how everything is connected because right now I was talking that we might consider a vulnerability a high severity, but the client might consider it lower. But sometimes it was actually the other way around. Sometimes we didn't consider something very severe, but the client knew how it interacted with some different part of the system. Or maybe that we didn't consider something serious, but the client knew that doing some stuff actually generates some costs. And if you can do that like without limits, then it's a pretty serious problem for them. Then, you know, it also can happen this way around. So yeah, like over all of these years, I really like playing whether an attack scenario is viable, whether it makes sense, and I always like to think about the preconditions for an attack. So, you know, the main question is, if we consider an attack scenario, and we know that the attacker has to be in a certain place to mount this attack, are there other attacks that are much, much simpler than that they can do, given this, you know, precondition? It's like I said with the XSS in Blogger, that was my first XSS reported in Google Bug Bounty. Like, if we can make somebody take a zip file from us and do something with that, then why would we bother with an XSS in, you know, a Blogger admin interface? We would probably be able to do much more severe stuff without having to have any, you know, vulnerability in the application itself. You maybe could just make them run DevTools and do something in that, or maybe just run an executable from the zip file. So yeah, that's the change that happened. But I think that's like, it just comes with experience. You see how people react for the reports, and then you understand also their point of view. And that not every vulnerability that you find is something that the world needs to stop to fix that. And there might actually be vulnerabilities that people might acknowledge, but they might decide that they don't want to fix that like right now, or maybe for the next couple of months. And it can also make sense whether you keep the threat model in mind.
Yeah, I think I started paying more attention to the actual impact in the sort of bug bounty world than in the pen testing world. In pen testing, I feel like there was more using of pre-written templates of bug descriptions and things like that, because when you report, you know, 10, 15, 20 vulnerabilities in 1 week.
By the way, I can interrupt. I actually hated that.
Yeah.
I mean, I didn't use template descriptions. I hated doing that.
Really?
Yeah.
Would you write a personal description of every single bug in pen test?
I mean, if for most of them, yes. Like only for like if I have an XSS, then I would always write a report like what you can do in the context of this application with this XSS.
Okay, that's nice. Well, now in the background, I obviously have to do it. In pen testing, I admit I didn't, and only, you know, in bug bounty, where you have to convince the other side in every single report that you have an actual impact, it taught me to also start paying attention to this during pen tests.
Yeah.
Back when I worked there.
I think that's I think that is good. Yeah. We had also some like pen testing clients who just accepted everything, whatever we write, they're okay with that. But yeah, we had at Securitum some, you know, pre-written templates for like many types of bugs. But I mean I used some of them, but I don't know. There's something in me that I just don't like use templated descriptions. I want to make it, you know, more specific to the application. Of course, it also depended on the scale, because if there was like an every possible bug in the application in every possible place, it also happened, then it probably doesn't make that much of a sense to describe everything. What I did, like if I had like many XSSes in a single application, that's also an interesting question. Like if you find the same vulnerability in different places, would you report it as a one bug with like different locations, or would you report it as a few bugs? And as usual, it depends. Like my approach was that, of course, when I do pen testing or bug bounty, It's usually black box, so I cannot see the source code. I don't know the exact root cause. But sometimes you can see if you have a few instances of probably the same bug. And when I assume that this is the case, that okay, this is like different locations, different parameters, different endpoints, but the root cause is probably the same, that I reported it as a run bug. But if I thought that there are several different root causes, then I would report this as distinct bugs. And the main reason, this is also really interesting, I think, that in the pen testing, we often do retests. So yeah, we report bugs, the customer fixes those bugs, and we need to do retests. And if I report like 2 different XSSes in, one bug, and then I do a retest, and one is fixed and one is not fixed, then it's more difficult to state that in the report.
Yeah.
You need to say that it's partially fixed. It's pretty bad. I mean, you can do that, of course, but I didn't like that. So if you have 2 separate issues, then you can say, okay, this one is fixed, this one is not fixed. It's pretty obvious. But if you report many different things in one bug, and they fix some of them, but like not all of them, then it starts being not that, it's just not easy to grasp what exactly it means, like partially fixed. You need to state exactly these endpoints are fixed, these endpoints are not fixed, and it starts being, you basically kind of start reporting this as a separate bugs, but in one bug. You need to make your description much longer. So yeah, and speaking of doing retests, it also taught me one I believe it's a very important skill, is writing proof of concepts. And I have a nice story here. It happened in the beginning of my career as a pen tester. Was that I did a pen test of some application, and the client came back with a retest, I think, a year later. So you don't remember about this application, anything, basically. And then I had, proof of concept or the description of the attack in the report. And I wasn't able to replicate that. It was too fake. It was too bad to be able to, if you don't remember details, then you cannot do that from the description alone. And I spent really long time trying to, remember what exactly I was doing, how I was able to get to this place to mount this attack. And yeah, that taught me that from that point, my proof of concept are really step by step. You need to click here, you need to go here. You need to make sure that you are logged in as an account with this and that privileges and stuff like that. And yeah, and basically my reason for writing better proof of concepts was that I should be able to reproduce that back from this proof of concept. It should be, or maybe to put it another way, if you have a person who never saw this application before, then that person should be able to reproduce the bug based on your proof of concept. That was my line of thinking.
Yeah, and that's good for bug bounty because sometimes we think that we report the bug to someone that knows the application really well, but the truth is that often it's triaged by a person who is responsible for many different bug bounty programs, and they do not know anything about the application you are reporting the bug currently. So I don't know who told this where, but I remember a tip from someone to actually include things like creating an account, logging in, using proper settings, setup or whatever, and only then doing the proof of concept. And I also see, I'm not a triager, obviously, but when I do the case studies, sometimes I study a lot of tens or hundreds of bug bounty reports of a particular bug class. And so obviously I want to, and I extract some information about the report. And I see that if there is a good proof of concept, like step-by-step reproduction, is the quickest way for me to like understand, okay, what is this report about, what's the impact and things like that. And then I often don't even need to take a look at the description and what they wrote about the impact, because the good proof of concept is replacement of anything.
Yeah, that's right. Also, yeah, also in Google, for instance, like there are also some people on triage when it comes to the VRP, Vulnerability Reward Program. And, Google has like thousands of applications, literally. And there are like, I don't know, 15 people on triage. So there is no way that they know every single application. And also, I think like a good way of thinking about it is that if you are a bug hunter and you spend a lot of time on a single application, then it's really, really likely that you know more about this application than any person from the triage.
Yeah.
So keep write as many details as you possibly can. You will make life easier for the people in triage. It will also make it easier to, grade your report and to understand what's the real impact is.
Yeah, especially when the bug is complex. And speaking about the complexity, when I look at your bugs from like 2013, 14, maybe even 15, those XSSes are often quite simple. And then you started getting deeper into this and reporting the more advanced XSSes, the mutation XSSes, the crazy stuff a lot of us don't even know about. How did this transition happen, and how did you learn those more advanced things?
Yeah, that's an interesting question, because I don't think I have a good answer for that, to be honest. I think it just came with, one thing that surely happened was that my approach in the beginning of my bug hunting career was that I was trying to find old applications. Basically, I was using some Google hacking and Google hacking on Google, and trying to find like forgotten old application on Google. And it was possible. There were like many of them. And at some point I was out of ideas. Like, what else can I do? At some point you ran out of ideas. And that was the point when I started to just digging deeper into the application that I know to find some bugs. And also another factor was, I think it was in 2015 or maybe 16, that Google introduced research grants. And the idea of research grants was that they gave money upfront to bug hunters to specifically look at certain applications. So, of course, if you report a bug, you get a normal reward, but the grant was supposed to motivate you to look at some application. And I think it really worked for me, because I looked at some applications, like, very, very carefully, digging very, very deep. And I tried to understand exactly what happens, what happens inside. And I knew that I won't probably get some easy XSS, like, you could just get parameter and you have an easy XSS. So I needed to understand what exactly happens in the application, how it transforms, processes the input, what are the sources, what are the sinks. So but I don't have like a good answer to like how exactly the transition happened. I believe that it's just something that comes with experience. And, when you report some simple stuff, you also maybe at some point you get kind of bored of that and you want to do something more interesting. And you start looking at like different stuff. Also, I think that for me, like many people, like during the trainings that I gave in my previous company, we will probably talk about it a little bit later. But many people ask me what is my methodology for finding security bugs in bug bounty or in pen test. And I didn't like this question because Some people have like some kind of methodologies. They like to do this, then that, then that. Maybe they use some other references like OWASP or whatnot. But I'm the kind of person that uses my punch, and I don't have any specific methodology. I'm just, clicking randomly on the application, seeing what it does. I'm trying to understand what kind of libraries it uses. And yeah, I just go with what my hunch says. And I know it's pretty bad from the, educational perspective because it doesn't give any practical advice to anyone. But yeah, that's actually how I approach. I just look at the application and I try to see something specific to this application, what can be a potential issue, and yeah, that actually works for me.
Yeah. What tools do you use for this? Is it mostly developer tools inside the browser?
Yeah, when it comes to the client-side issues, then yes, I use dev tools in Chromium, and let me think. Yeah, I think that's pretty much it when it comes to frontend. I sometimes write some scripts for myself or some browsers extension.
What do they do?
Sorry?
What do those scripts do?
They usually do something automatically that would be too tedious to do that manually, like some kind of transformation, or like one of the things that I actually made public was a script for finding prototype pollution gadgets. So it took a snippet of JavaScript and it transformed it in such a way that if the script is trying to access a non-existing property, then it is a possible gadget for client-side prototype pollution.
Yeah.
Sometimes I'm just adding some logging because I'm just interested in what happens exactly on the application. But in most cases, that was like pretty.
So basically, just things to sort of speed up the feedback loop
exactly.
of what happens. Do you often debug the JavaScript inside the browser, or do you rather statically read it?
Yeah, I'm a big proponent of dynamic analysis. I think that's my main tool, how I work with the code.
Yeah.
There are pretty nice tricks actually in the Chromium DevTools that I believe are not widely known. Like for instance, that there is a function called debug that you can use in the DevTools, and you can pretty much debug everything. You can even debug a setter on inner HTML or stuff like that. And I really like to use that, to find the piece of code that is interesting for me quickly. There are also features like, practically everybody who used like debugger knows that you can set a breakpoint in the DevTools, but you can also set like a conditional breakpoint, so that breakpoints that is fired only if certain conditions are met. But also you can have, I think it's called log point. So it is not a breakpoint, but you can, just do a console log in this line whenever this line of code is called. So your code is not stopped, because sometimes it is pretty annoying, especially when the application is doing like a lot of stuff. For instance, if you try to set a breakpoint on post message in any Google application, then your debugger will stop like every single second. It's just not usable at all.
Yeah.
So this kind of tricks is what I'm using. I also, I don't remember what or why exactly I did that, but I remember that at one point I also used the Chromium, I used the Puppeteer, it's called, I think, the Node.js library for controlling Chromium.
Yeah.
Because, I don't know, the application was doing something annoying and I wasn't able to work with that. And in Puppeteer, I was just intercepting the JavaScript, and I was changing something in the JavaScript, so it's not that annoying. That was changed.
Okay.
I don't remember details, but I remember I did something like that.
Okay. This use case I didn't know about, but for our listeners, in BBRD I just finished like 4-part series about DevTools, and all the things that Michał described here are there. So you may want to check this out. One thing I learned while writing those articles and while writing the docs is that you can reset frames while debugging, so you can run over the same function over and over again, which I didn't know about, and it also speeds up the work massively.
Another trick that I like to use is, for instance, assume that you test an application that uses some kind of HTML sanitizer, and sometimes it is pretty annoying to do that like directly from the application, because I don't know, you need to pick some checkboxes, or you need to press a button every single time and stuff like that. So I also like to find the place in the JavaScript code that does the sanitization. The assumption here is that it's client-side sanitization. And if you can get a reference to the function, like it a debugger, because the nice thing about using the debugger in Chromium or in any other browser is that if you execute a command in the console, then you are in the context of where you're currently stopped. So we can use the local variables and stuff like that. So if I can find the method which performs the sanitization, then I can just go to the console and call it directly without doing all this user interface stuff. And it also
that's a good tip. How would you find this function?
Yeah, that's an interesting question. There might be several ways to do that. I might assume that if the application is doing HTML sanitization, then it uses a browser-provided HTML parser, such as like the DOM parser, parse from string. So I might try to set a breakpoint on that. I might try to set a breakpoint on on setter of inner HTML. It is also possible, like if you know that the sanitized HTML is put somewhere in the DOM tree, then in DevTools it is also possible to set a breakpoint whenever a DOM node changes. So you can set a breakpoint on a certain DOM node, for instance, if any child is appended. So then you can do that if you know that this is where the sanitized HTML ends up, and then you can go up through the stack trace to find the place, because if you know that it is outputted here, then somewhere near, hopefully, it is generated. So I focus on either the sink or the source. So I'm trying to think. And sometimes if you assume that there is a sanitizer, you can just look for the word script, because like if there's one tag that every single sanitizer strips out, and it's script. So you might be able to find it, just by looking for some strings that you assume that the sanitizer will have.
That's a good tip right here. And what are your tips for reading? Because I saw also some of your work was that you found out new stuff or in the browser, or new ways to define something in the browser. How do you get knowledge about those changes in the browser?
Basically from Twitter or X.
Okay.
I follow people who, among people that I follow, there are also people that work in browsers, like in Chromium, in the Safari team, or in the Firefox team. And when something new happens, then they like to tweet about it. There are also some Twitter accounts, like I don't remember the names, but something like Intent2, I think it's called, because there is a process in all browsers that if they want to introduce a new feature, then they do something like intent to experiment, intent to ship, and stuff like that. So there is some kind of documentation that they want to introduce something new, and then you can get the information about that from these sources. Sometimes these are just random tweets. I remember that a few years ago I did a security analysis of Portal element, and
Yeah.
introduced only in Chromium. And the inspiration from that was from a tweet by Frederick Brown, which, by the way, is in the Firefox team. And that was a tweet, something along the lines of, hey, you have a specification for the Portal element, but it doesn't have any security consideration. And I thought, that's interesting, because, I mean, the security considerations might be empty because this specification doesn't really relate to security. That might be the case. But also, maybe nobody really thought about the security considerations. And yeah, I believe the latter was the case in Portal, unfortunately for me at that point.
What happened later with the Portal element?
I'm sorry?
What happened later with your research on the Portal element?
What happened after is the question? Yes.
Because I think I saw your bug using the Portal element, the same origin policy bypass.
Yeah.
Yeah. How did you get from reading the tweet into finding the same origin policy bypass?
I see. Yeah, I read the spec, and I was just trying to understand why do we even need portals? What does it even do? And it is similar to iframe. That was the first thing that was easy to notice. But it's not exactly iframe. The main difference was that in Portal element, you could call a method, I think it was called activate. And then the Portal element is like upgraded to be in the top frame, like instantaneously without any reload. So the first thing that I could notice was that, okay, it is similar to iframe. And in iframe, one thing that you can do is that you can set the source attribute to like JavaScript alt1. So yeah, I'm trying to do the same thing on Portal, and it worked. But the question was, in what context does the JavaScript execute? And it turned out that in Portal, the JavaScript executed in context of the page that was already loaded. It was pretty much equivalent to what happens if you just, paste the JavaScript into the address bar. So if you enter the JavaScript, like JavaScript colon and stuff, then it executes in the currently loaded page. And if you try to navigate Portal, then it was pretty much equivalent to enter some stuff in the address bar. So if you were on like accounts.google.com, that was my example, and you could, enter JavaScript in the address bar, that if I try to navigate Portal to JavaScript, then it executed in the context of accounts.google.com. But, when I got the idea that this is equivalent to entering an URL in the address bar, then the natural next step for me was that, okay, but in the address bar, you can also navigate to a file URL. You cannot do that in iframe. I mean, you cannot do that in iframe if you are in the HTTPS protocol, because this is like, it is not possible to navigate to local resources from HTTPS. But in Portal, when I tried to navigate to file, it worked. It really showed that file in the Portal. So what you could do was that you could navigate to file URL, like etc password, and then you can navigate to JavaScript to get the content of that etc password. So that was not only same origin policy bypass, but it was also reading local files, which is even
really
worse. But yeah, I think that this bug was, I think it was kind of obvious. I mean, in a way that it was the really natural thing to check. Like, okay, it is similar to iframe. In iframe, this thing is blocked. Let's see if it is blocked in a Portal. And it wasn't.
Yeah.
And that's pretty much the story about Portal. I found like 5 or 6 bugs, I think. And most of them were like, okay, this is normally blocked. The question is, is that black portal? It's not bug report. That was the start.
Do you know if the portal element, because back then it was in experimental mode or something like this in Chromium?
I think it still is. I don't
Still
think
is,
it's
okay.
actually used. I mean, they obviously fixed those bugs, but yeah, it's still. I think it's also not under the enable web, experimental web platform features, but it's under a separate flag, like enable portals.
Okay.
So even less people have that.
Yeah.
There's also an opposition from other browsers. So I'm not really sure what is the status of portals. I know that there were many security issues because like I found the security issues and some other people, when they found out that something called portal even exists, they started to look for other issues. And I know that there were several like memory corruption issues in portals as well.
Oh, wow.
So it was really a gold mine for bug hunters.
Does Google pay normally for features that are experimental, or they have like lower bounty table for them?
I'm not exactly sure what the policy currently is, to be honest. I think the policy changed a few times in the meantime, and I'm not sure I'm not sure if the bugs would be rewarded today, to be honest. Maybe they would, maybe they wouldn't. I don't know
Okay.
what is the policy.
Okay, and also this is the bug in the browser, not really in a website.
Yeah.
And it's also a shift that was present in your career.
Yes.
What was your drive to looking at bugs from just bugs in normal websites to bugs in browsers?
Yeah. As I mentioned, when it comes to bug hunting, I focused pretty much on Google Web Applications. And at some point, it started to be more and more difficult to find bugs in like XSSes or the client-side issues in Google, also the server-side issues in Google applications that are not like acquisitions, because acquisitions have many bugs, but the rewards for acquisitions are much lower. And yeah, I was interested in, Google.com domain, basically. And at some point, it started to be more and more difficult. And, my feeling, my hunch, was that there might be more bugs, but they might be difficult to find using black box approach. And the really nice thing about looking for bugs in browsers is that all browsers are open source. I mean, all the engines are open source. And if you believe that you are onto something, then you can just look at the source code. You can find what exactly happens. It's not always easy to find like exactly what part of the source code is responsible for the function that you are currently testing. But the easiest way is that if you have any error message, then it's usually the easiest way to find the binary message placed in the code. But yeah, I think that the portal element was actually the first thing that I did that was related directly to the browsers. And I believe that it actually motivated me to look more. So one thing was that it was more and more difficult to find bugs in web applications. The other thing was that you have source code of the browsers, but also it just didn't know it before that when I tried to find some bugs in a browser mechanism, then I was able to do that. And that was a really interesting lesson for me. That's, by the way, I think that's general my lesson like during my whole life is that you might have some assumptions whether you are good at something, but this assumption might be wrong. I mean, you might think that you like doing something, but when you do that more, than you started to see that, okay, it's not actually what you like. And the other way around, you might not because I think that before Portos, I didn't even think about testing browsers. But okay, I tried that, and yeah, it went well. Like in the beginning of my pen testing career, I thought that the most interesting area of pen testing is the infrastructure. I remember that I saw some presentations about Metasploit and stuff like that, and I thought it's super, super interesting. And I wanted to do infrastructure pen testing. And I did a little bit. But it just happened that I was better at doing web, basically. So, at some point I decided that I don't think that I want to do the infrastructure anymore, at least not like much of it. And I want to focus more and more on web because it just happens that I'm better at it. And I think that's a nice place to share also a funny story. How my interest in like security in general started, because it was an infrastructure thing. I think I was in high school at that point, and I already knew a little bit of programming. I programmed in Python and Visual Basic. That was actually my first programming language. And I knew some stuff around, but networking was like pure magic for me. I didn't know at all how networking works. And one day, like randomly, I found an article on Wikipedia about ARP spoofing. And, I always assumed that what happens in the network is like some magical, super advanced algorithms. But then you read how the ARP protocol works. And it's like super, super simple, super naive. And then you see how the attack works. And the attack is like super easy in theory. Basically, for those of you who don't know, the basic idea of the ARP spoofing attack is that, imagine that you are standing in front of the group of people and you are asking, who is John? And you assume that the John will raise his hand. But somebody else might raise their hand that, hey, I am John. And then you give something that was supposed to go to John to that person. And this is pretty much how it works in networking. We trust that when we ask, who is this IP address or this MAC address, then we trust that the right machine responds. And then I learned about a tool. I don't remember how it's called. Anyway, it doesn't matter. But there was a tool with which you could mount the ARP spoofing. And I tried that in my local network. And, it was in a year before like HTTPS everywhere. So It was pretty nice that I could tell my brother, hey, go to this website. And suddenly some other text showed up. And yeah, that was pretty much my first proof of concept that I did of an attack, that, some random text change on some pages because everything was under HTTP. And yeah, at that point, that was really a turning point for me because, hey, the network is not pure magic. It's actually pretty simple. At least some of the protocols are simple. Not all of them, of course. But yeah, so it all started with infrastructure thing, and now I'm not doing any infrastructure at all.
To be honest, when I started learning about security, I also wasn't attracted to web security at all. I don't really know why, but I thought I want to do like reverse engineering or something in this direction. And I think I was just afraid of complexity of the web. And then I just started learning it for some reason, and I got into it. And apparently it works well. There's also a good book called, I think, Be So Good They Can't Ignore You. And it really touches upon the fact that to like something, you just have to become good enough at something, and then you sort of start liking it.
Yeah.
And it's against people that are saying that you have some natural abilities for one and one profession only. And I think the book is really good. I can recommend it to anyone but the takeaway is just when you are getting good at something, then you sort of start liking it naturally. Obviously, that's not always the case. I do think that people have some predispositions. Are they more analytical or more relationship oriented or whatever? But within such a space as security, where it's pretty much similar skill set, I think for most people, they could like a lot of different branches of security, and they could jump around
Yeah.
and learn pretty much anything.
Yeah. The nice thing is also that if you know like one area of security well, then it's easier to jump into another one because you have some background and you understand like what's it all about a little bit better, even if it's like, I mean, if I was supposed to do, I don't know, a Linux exploit development, then I would start pretty much from zero. But I think like given some of the background that I have, that would still be easier for me to jump into that topic than to a person who didn't have any experience with security at all.
Yeah, 100%.
So yeah, that's also nice that all this experience that you have can also be useful. Or maybe like if you have like different kind of background than other people working in this field, that could also be useful because this background might come useful in certain situations. Like if you mentioned reverse engineering, so if you are a reverse engineer with good knowledge about web, it can come useful if you happen to reverse engineer something related to web in some way that the other people might not be very familiar with.
Yeah, and speaking of learning, I have never found a prototype pollution bug. And what would be your tips for me to find one?
Yeah, that's interesting question, because in bug bounty I also didn't report a single prototype pollution bug.
Okay.
So that's also a little bit of a shift. Like at some point I started sharing more research stuff instead of just bugs. And I just found prototype pollution interesting. I mean, okay, we might say that I reported some bugs, but it wasn't in bug bounty. It was like, I don't know, I think I reported that to Don't Purify or some other
How about the
sanitizer.
Kibana RCE?
That's also an interesting story. That's a bug that wasn't found by me. It was just found by somebody else. I don't know even by who, to be honest. The story here was that during a training organized by Securiton, there was one participant that said that he wants to, understand prototype pollution better, and found this Kibana vulnerability which doesn't have a public proof of concept, and he was able to find like what kind of module has this vulnerability, and we can look at that and maybe we can find some kind of scenario. So that's also something that happens a lot, like in my career, that some things happen by accident pretty much, because the prototype, if it wasn't for that one participant of the training, then I mean maybe I would have dived into prototype pollution a little bit later, but that was the motivation. But anyway, prototype pollution was more of a research project for me. I just found it interesting. I believe that this is not a bug that is, much talked about, and it was just interesting for me from purely technical perspective, and I was just trying to understand how viable this attack scenario is. And of course, I did try to test some like Google properties for prototype pollution, but I wasn't able to find any bugs. Yeah, but when it comes to tips, I think there is a really good research. I think it was called just something like exploiting client-side prototype pollution, something like that. And they shared some techniques, how they found the sources for prototype pollution. Like if you are looking for client-side prototype pollution, then you can just randomly add a proto parameters to get to post to JSON everywhere, and you can just look into your browser DevTools and to see if you can see new properties on object prototype. I think that the way Chromium sorts the properties, it's like a side effect of an implementation, is that the new properties are always in the beginning. So if you look like an object prototype, then your new properties should be at the beginning. I'm not 100% sure that it happens, but I think that was the case. I also think that the Burp suite has some new features related to prototype pollution, but I didn't have much chance to test that.
There is the DOM Invader, which is like a browser extension actually, and I absolutely love this extension for DOM XSS, and it also has some features to find proto pollution, but the proto pollution features I haven't tested actually. Now I think I probably should turn it on and see what comes.
Yeah, that might be interesting to see what kind of issues it can find.
Yeah, and speaking of trainings, what kinds of trainings did you lead and for who?
Yeah, so during my last few years at Securitium, I was really focused on giving trainings, public talks, basically on education. And so I had many different trainings. The most popular one was called Web Application Security, and it was a 2-day workshop about SQL injection, XSS, authorization issues, authentication issues, server-side request forgery, and stuff like that. And we just taught people about security issues they can expect in web applications by showing them how they can be exploited. The participants got like a training license for the Burp, so they could work with that themselves. And yeah, the basic idea, the usual target for these trainings were developers to try to teach them about web security and what kind of security issues they can expect. And I remember that like in the beginning, I kind of expected that, when people leave the training, then they should just write super secure code after that. And because, they learned everything they need to know about at least the basic security stuff. But at some point I understood that this is not what happens. And I considered a success of my training if a person can recognize a security issue. Like if when they write a code, then they can, have suddenly a light bulb above their head that, hey, I think there might be something wrong with this code. So my goal was to build some kind of intuition, because if we talk about some specific security issues, but we can also try to generalize them a little bit. And like I would consider a success if a person, when writing a code, think twice, hey, this probably is something that might be not safe. But also something that happened a few times during the trainings was that like after the first day of the training, people started to test their own applications. And on the second day, we started the training and they say, hey, we found this bug in our application. And that was actually super cool. That was one of the best things that could happen on the training, because, you immediately, that for the people, it was worth it to go to the training.
Yeah. What did you see them getting wrong the most often about security?
Um, I think the understanding of attack scenarios, the stuff that we talked about before, because an example, one of the arguments that was brought a few times was that when I say that we have like client-side HTML sanitizers, and that you probably want to use client-side HTML sanitizers because you use exactly the same HTML parser that is used by your browser, so it makes sense. And then some people would argue that, okay, but if it is client-side sanitizer, then, you know, you can disable it or stuff like that. If it happens on the client, how we can trust it? And yeah, and that was the point when you needed to kind of describe what is the threat model. And I believe that it is really widely misunderstood. I mean, it's not easy if you don't think about it that much, and it's really easy to misunderstand. But I also had a training like that was called front-end security training, and it was about XSS. Basically, the whole first day was about XSS, and the second day was about other front-end issues. And yeah, the thing that I was I was hoping for the people to understand was that the attack scenario here, basically for most front-end issues, is that you send a link to someone and then you can do something. Because if we start talking that you can do something in the dev tools of the browsers, or that you can, I don't know, intercept the HTTPS traffic, in theory you can do that. You know, if you have some impossible supercomputer or you find a bug in the algorithm, you can do that. But this is not something that we care about in context of issues like XSS. Like it's just completely outside of the threat model. And it is very tricky, like how to describe that to people so that they understand, like even HTTPS, which is like the most widely deployed security mechanism in the world. There were people who asked, like, if the site had HTTPS, why did they have a security breach? And and we might laugh about it a little bit, but it's actually really tricky, like educational issue. Like, how can we make people understand what they are protected against when they use HTTPS or any other security mechanism? Another good example, I believe, is that if you have an encrypted messenger on your like WhatsApp or Signal or whatever, you know, end-to-end encryption, nobody can read the messages. But if you leave your phone unlocked on the table, that it doesn't matter if the communication is encrypted end-to-end, because anyone who can just take the phone can read the messages. And and sometimes, you know, in the internet, you can see some comments or discussions that, hey, they use Signal, it has end-to-end encryption. How the, you know, government organization was able to decrypt the message. And they probably didn't even have to decrypt anything. They probably had direct access to the screen. So it's really, really tricky because we have many, many different mechanisms that prevent some specific attacks. And people who, I mean, I believe that people should have some general understanding about security. By the way, I really think that it is something that should be taught in school, you know, in the informatics lessons, like some basics. I mean, I don't know what is currently being taught at school, so maybe it is. Actually, but so people, you know, should have some general understanding, but I can understand that they don't need to know that HTTPS like also keeps the integrity of the data, because like when you talk about HTTPS, you usually think that it encrypts, but it's not all it does actually, and it probably doesn't matter for most people that it also checks the integrity of the data. But it is actually, from the cryptographic perspective, super, super important. If it wouldn't do that, then it would be a really bad protocol, to be honest. So yeah, that was tricky, because if you get a question about, security, about the threat model, about the attack scenario, and that it's very tricky to answer that question, to describe it without some broader context. And yeah, I of course there were like other things that people got wrong, like I don't know how to use Burp. I mean, I love Burp, but let's be honest, user interface is not the best in the world, especially when you need to use it for the first time. But that's something that you can just learn. But the attack scenario, the threat modeling is something that you need to understand, kind of get that, what's it all about. So yeah, I think it mainly came up in the front-end training, that, stuff like, does it make sense to have some kind of security mechanism in the browser? Because like, you can bypass everything that happens in the browser. That was the argument usually. Yeah, you can. I mean, the argument that I typically use is that just because you can do something on your own computer, it doesn't mean that it's easy to do on somebody else's computer. So you can run DevTools in your own browser and you can delete everything. You can change the code as much as you like, but it doesn't mean that it's easy to do on to someone else. And I think that's the shortest answer to this question. But yeah, it's really interesting to dig deeper. And it's also very relevant, to pen testing and to bug bounty reports, to also understand the threat models and if something is a vulnerability or how severe of a vulnerability that is.
Yeah, I think also from my experience, as I don't do trainings now, but I used to, and I think server-side vulnerabilities are so much easier to explain to people than client-side stuff, because with XSS you have the same origin policy, you have different types of XSSes. For example, when you have an XSS in the uploaded file, it's really hard to explain to the person that if it is a sandbox domain, it's not a risk. But if it's a normal domain, it is a risk, even though there is nothing on the page, but you can do the request. There's so much complexity there that I really think XSS, even though it's the most popular vulnerability type, I think, from the web vulnerabilities, it is super complex and super misunderstood.
Yeah, that's right. I also think that the typical proof of concept for XSS also doesn't do it any favors, because if people always see the alert one, they don't have any idea what you can realistically do with. That's basically like what I started with my trainings before even saying what XSS exactly is, how you can exploit that. I was just showing like a real example that you can get some data. Like I had a demonstration that you could take over an admin account in WordPress thanks to XSS. So I started with that, and I was just saying that from now on, we will see mostly alert one, but keep in mind that instead of the alert one, we could do all the stuff that I just showed.
Yeah.
That was my idea. But I think it was only new for many people. So like at the second day, some of the people kind of forgot about that and asked again, like, okay, but yeah, I have it, but I can do alert one, so what? And yeah, but I also learned I remember that when I started doing trainings, I think it was in 2014 or 15, I assumed that people will know more about security in general. And I thought that there are more stuff that are widely known that there actually are. And like, for instance, something that kind of surprised me, but it doesn't surprise me anymore, is JSFAQ, which is a way to write JavaScript code. It is really widely known among, security people, because it's very useful. If you want to bypass some filter, then you can perhaps use it. But for developers, if they are interested in some low-level details of how JavaScript works, then they know about JSFAQ. But many people didn't even hear about it, but it was kind of surprising for me in the beginning because it's like super interesting stuff about JavaScript.
Yeah.
But the thing is that they don't need to know that at all, because why? They don't need to use the strings. Like they don't need to know that you can use, I don't know, array constructor to have access to a function that works like an even. It's super useful for security people, but developers don't need that.
Yeah, I've had a similar realization one day when I think we were talking with the Java developer while developing a Java deserialization exploit or gadget or whatever, and or asking them about some like reflections or whatever, and they just didn't even know how to execute system level code in Java because it is actually a good thing because they don't do it in normal web applications, and and we know a few ways in every single language how to execute code.
Yeah, so yeah, that was a really that was a good insight that okay, that the developers need other stuff than security people, and something that might seem obvious for us isn't really obvious or even relevant for them. Like on the training, I also had some challenges related to SQL injection, and you needed to bypass some filter, encode the data, escape it somehow, and yeah, people didn't know many of that stuff because, let's be honest, if you need to write a SQL query, then you are a developer and you would try to write it as legible as possible. And when we are trying to bypass some filters, then we are doing pretty much the opposite. We are trying to use as many obscure facts about how SQL is parsed and possibly can. So yeah, at some point I understood that, okay, I know that we probably, I had some kind of cheat sheet from some point that here are some useful features of SQL, JavaScript, whatever that you might need in the challenges. But yeah, I remember that like in the very beginning, I was so surprised that how can people not know that?
Yeah, okay, Michał, last question. I saw you started a YouTube channel yourself recently. What are your plans regarding this?
Yeah, so my plan, I don't have any specific plans what I want to do with the channel. Probably I will have some videos. My first video was not technical, at least not that technical, and it was pretty well received, which I think is pretty nice. And I'll have some other ideas to other topics that I want to talk about that are not purely technical, but I think people might find them interesting. Like one of the topics is like the attack scenarios and the threat model, and like to understand what we can do with some kind of attack. I specifically want to talk about HTML sanitization on the client and why it makes sense, because recently I saw a YouTube short. I don't remember what was the channel, but it was about the sanitizer API that is introduced in browsers. And there were like many comments under that video about the sanitization must be done on the server, because if you have it on the client, then it's bad. You can bypass it, you can remove it, disable it. And yeah, that was an inspiration for me that, okay, I think that that's something that we have to explain to people so that they understand that it actually makes sense to sanitize on the client, and that's a good excuse to have a little bit of a broader talk about threat modeling, I think, in general.
Yeah, we'll link this video in the description. I watched it, really nice stories about bugs from Michał's bug bounty journey. For now, Michał, thank you so much for joining me today. Loads of knowledge for me and for my audience. Where can people find you to follow you in the internet?
I think the best place is on Twitter or X. My handle is SecurityMB. And from that, you could see links from all other places where I'm currently at. But basically, I'm using mainly Twitter.
Okay, once again, thank you so much for joining me today.
Thank you for the invitation and for the nice talk we had.
What a great episode! If you want to watch the video on Michał's channel about his bug mounting reports, check out the link that's in the description. And if you want to listen to another interview, I suggest you this one with Johan Carson, who went from nothing to 6-digit bug bounty earnings in only 1 year. For now, thank you for listening and goodbye.